Look, let's be honest. I said I was going to release a document, and clearly we haven't. Okay, April Fools. April Fools.
We're talking about universal theories of everything, perhaps a new one created by today's guest, Eric Weinstein. And that goes by the moniker geometric unity.
What we're talking about is crazy. I think it's really important to just own up to the fact that for people who want sober physics, this is probably not the channel for you today. If we look at our history, everybody who's proposed new physical law and gotten it right had errors. The problem is that we're not in an adult phase where we faced up to the fact that we have almost 50 years of stagnation. And what you're seeing with this proliferation of new claimants to have fundamental theories is in part that string theory has finally weakened itself, and the aging of the particular cohort, which is baby boomers who are the string theory proponents, they've gotten weak enough that effectively other people feel emboldened. And I think, Stephen Wolfram said this recently, that in a previous era, he would have expected to have been attacked. But we've been waiting around for so long that perhaps the political economy of unification and wild ideas has changed somewhat.
What are the inputs? There are the players, the matter players, there are the gauge bosons, there are new predictions, there are new concepts.
But there's a lot of weirdness. Why the Lorentz group? Why SU3 cross SU2 cross U1 for the internal symmetries generating the forces? Why three families? And I thought that something that many younger viewers may not be aware of is that things really changed around 1983, 84. And if you think about the original anomaly cancellation of Green and Schwartz in 1984, I believe, you could ask, what was physics like right before that moment? Mm-hmm. And I think it's absolutely shocking, because we don't realize the extent to which the string theorists really redefined what the major problems in physics were. I think most people in the post-string era somehow believe that the major issue is quantum gravity. And I just find it astounding, because that's really what the string theorists were selling. So I think that a lot of things got done to shore up what we do to mature input into a quantum theory. It wasn't physics per se. It was sort of the mathematics of physics. And I think that was very frustrating, which is, it's sort of, to physicists, it's yeoman's work. They wanted to go to Stockholm, and they ended up, winning the first Fields Medal won by a physicist. And I think it's weird. It's like, what is your time? Your time is whatever it is that can be done. And they thought their time was to quantize gravity. Well, guess again, nature said, we have something incredibly important. So I feel like I'm trying to rescue their legacy. They want to go down as string theorists for the most part. And they want to say that string theory was the most successful of any claimant. Maybe that structure ultimately carries the day. But I do think that the idea that they're entitled to this many pivots without having to become self-reflective is preposterous.
What do you say to the younger people who say they can't understand it? They can't comprehend geometric unity.
We can say what geometric unity actually is. We can draw pictures. People can get it. In fact, I was talking to my good buddy Joe Rogan earlier today, and a particular group of people who listen to my podcast put up a site for Joe called Pull That Up, Jamie.com.
Jamie, could you bring up something called Boskin Wild versus Mild?
I know what you're saying.
Because I want to be joyous. I want to produce positive things that uplift us, that give us a hope of breaking like the Einsteinian speed limit. If this is wrong, I want to know.
We've had insufferable members of our community for a very long time, and we should not be getting rid of insufferable people. The problem is what happens when people become insufferable and they don't constantly check in with the unforgiving nature of the universe. We have a problem that sociologically nobody wants to say that the Institute for Advanced Study has like the smartest guys around, and a lot of what they do isn't physics. In standard terms, it's the mathematics of physics.
Yeah.
And these are uncomfortable truths, just the same way that it's uncomfortable that we're taking seriously somebody who's been out of the field for 27 years. But these are end times. We're having end time conversations. And I think that it's we don't need to be mean about it. I think we just need to be more honest. That ship that you're seeing is called curvature. And it has 3 masts because it has 3 irreducible components usually. One mast is called Weyl curvature, one mast is called traceless Ricci curvature, and one mast is called Ricci scalar. And the first greatest insight maybe of the 20th century was the way in which we could feed back the curvature of the Levi-Civita connection into being a covector field on the space of all metrics. And this is depicted as a boat going into a bottle that has a rather wide opening. So we've got a metric, the metric has a connection, the connection produces curvature that's Riemannian. We find that by identities it's got 3 components. It tries to go towards metrics and the Weyl curvature is snapped off. Afterwards, the scalar curvature is lowered somewhat or adjusted by scalar curvature over 2 times g mu nu. And so symbolically, what we've done is we've said Einstein threw away the Weyl curvature, readjusted the Ricci scalar curvature, and fed metric information through to the Levi-Civita connection, through to the Riemann curvature tensor, and then played these projection games to feed it back to the space of metrics, and that particular combination is perpendicular to the action of the diffeomorphism group on the space of all metrics, leading to a divergence-free condition via our friend the Bianchi identity. So let's see whether general relativity and gauge theory have an incompatibility problem as we try to play the same game. We start off with the Riemann curvature tensor, but now the neck is narrower. And what's really going on is that this is kind of evocative of trying to feed it into the space of connections, but the gauge group acts differently on 2 different factors, namely, if connections are add-valued 1 forms and curvature is an add or Lie algebra valued 2 form, the problem here is that gauge transformations act on the Lie algebra component and don't touch the form component. But Einsteinian projection or contraction or summing over g mu nu indices is democratic. It deals simultaneously with the form piece and the Lie algebra piece. So if you treat only the Lie algebra piece under a gauge transformation and you don't touch the form piece, then contraction followed by gauge transformation will never be the same thing as gauge transformation followed by contraction. So here's a GU approach. How do you get geometric harmony between general relativity and gauge theory when you have the ship in a bottle problem? And this is kind of almost a tight analogy. You've got the curvature tensor. You apply a gauge transformation to 2 of the masts, and you pass them through into add-valued d-1 forms, and then you do an inverse gauge transformation, which is exactly how you do the ship in the bottle trick. By the way, Brian gave me a wonderful ship in a bottle. Thank you very much.
You're welcome.
Raising the masts inside, and then you can potentially, if need be, adjust one of the 2 masts again in order to get agreement. So in part, the idea is, how do you get harmony? Let's imagine that we have a salary that is constant in dollar terms over time, but somebody is facing inflationary pressures on their basket of goods. What we now have is a $10 an hour salary, and if we claim that it's constant means derivative equals 0, yes?
Mm-hmm.
But we know that it's not constant purchasing power. So we have two notions of constancy. How are they related? We do a gauge transformation. You now see that these little hash lines are the reference levels that we call a connection, and we decide that rise over run should not be measured from a naive horizontal, but should be measured instead from a custom reference level represented by the hash mark. That situation is actually an application of gauge theory to a very simple problem in economics, completely depicted by stretching the fibers in the XY plane. Toy model of space-time. So going around through the center is like Groundhog Day. You come back to the same place, and it's a repeating time cycle. And space is simply a circle. And what you're seeing here is something that's very hard to picture because it's 5-dimensional. But one trick here is because the torus has a property called parallelizability, the object on the right is a potential metric at any given point on the torus. So in other words, if a metric is a symmetric non-degenerate 2 tensor, if you think of it as a matrix, it would be of the form x, z, z, y. And the non-degenerate means that x, y minus z squared is not equal to 0. So that's what's cutting out that variety, if you will. The zeros of the determinant would be points, given that there are 3 degrees of freedom in the metric. And so instead of actually having a metric space-time, GU would say replace the torus by the entire space in that sort of hourglassy region. So the top region would be like space metrics. Mm-hmm. The bottom region below that sort of weird diaphanous scarf is time metrics, and the weird middle region, which is sort of around that singularity, would be space-time metrics. Every way you can stick that donut into that middle region without touching one of those two sheets is a valid space-time metric. And what GU would do is to say, don't only dance on the points of the two-dimensional torus. You should actually have fields that are dancing on all of the points of the torus and simultaneously all of the points in that middle region. Now notice that thing up in the top left, which is a ruler protractor combination. Those two sliders are recalibrations of what it means to be one unit. And that protractor is a recalibration of what you're going to define to be 90 degrees. So every way of keeping that bottom arm in a single horizontal position, moving the top arm and moving the two sliders, that's 3 degrees of freedom in the space of metrics. So that's a different depiction of the space of metrics. So the big take home from the restrictive version of GU that we're exploring here is that if you allow fields to dance on the space of metric apparatus, measurement apparatus, then the kind of the paradoxes of measurement start to make a lot more sense. But so the point is that spinners on 14 look like spinners on 4 tensor spinners on some version of 10.
Yeah.
And whether you're talking about spin 10 models, SU5 models, or SU4 cross SU2 cross SU2, which is spin 6 cross spin 4, isn't that exactly what we see in the standard model? Mm-hmm. A particularly intriguing feature of SO10, which is really spin 10, or could be spin 6 comma spin 4, is its spinner representation used to house the quarks and leptons, in which the states have a simple representation in terms of basis states labeled by a set of plus and minus signs. Perhaps this suggests composite structure. Now here's the sentence that just floored me. Alternatively, one could wonder whether the occurrence of spinners both in internal space and in space-time is more than a coincidence. And then he pulls back immediately. These are just intriguing facts. They are not presently incorporated in any compelling theoretical framework as far as I know. Geometric unity is that compelling framework. And one of the things I'm looking to do is I'm looking to get constructive feedback from people who want to help me succeed as opposed to people who just want to be dicks. And what I would love is to bring your positive energy.
Reveal.
Go to geometricunity.org physics is the most honest way to ask the most grand questions in the universe.
Absolutely.
If physics is grandiose, then we've got real problems. Then grand doesn't exist. And if grand doesn't exist, then grandiose doesn't exist. So my feeling is no. This is the actual grand quest, and we're not going to back off it and be pussies about it.